Good morning, children. Regarding the simple harmonic motion, we have studied the details, displacement, acceleration, force and energy and everything. So, today I will discuss the examples of simple harmonic motion. Okay. Now, the first example of simple harmonic motion is a simple pendulum. So, everybody knows what is a simple pendulum. When a heavy mass is suspended by a string, inextensible string means what? Due to its mass, it should not get extended. That is known as the inextensible string. So if you suspend the heavy mass from a string, then it is known as the simple pendulum. And how a simple pendulum oscillates? You just see, if you displace this position O, this is known as the mean position. Now suppose you have displaced the pendulum from O to B. So you see, you have displaced it by an amount x. Means what you can write, the displacement of the pendulum is OB and it is equal to x. Let us consider O to B. Now you see, when you have taken it at the point B, then the weight of the bob, it is acting vertically down. Just follow this line. So mg is acting in the downward direction and tension in the string, it is acting towards the point of suspension A. Alright. So you see, if you consider this angle is theta, then if you extend this line, this angle will also be theta. Why? Because this line and this line, they are vertical line, they are parallel to each other. This is the transversal, so these are the corresponding angle. So this angle is theta. So you see, applying the concept of vector, what you can do, you can break the weight into the component mg cos theta along this line and mg sin theta along this line. So if you look at the diagram, then you see T tension and mg cos theta, they are getting balanced with each other. How we can make this conclusion? Because neither the bob moving towards the point of suspension nor it is coming down along mg cos theta. It means what? T and mg cos theta, they are balancing each other. So this is the unbalanced force mg sin theta, due to which the bob is moving towards the main position. Alright. And you see here, this force, as it is acting towards the main position, it is trying to restore the main position. So what is the name of the force? Restoring force. And already we studied that in case of simple harmonic motion, always a restoring force acts on the particle executing SHM when it is displaced from the main position. So in this case, what is the restoring force? It is mg sin theta. Alright. Now you see, you can write what is sin theta. Sin theta will be, you see, this angle is theta. So sin theta will be OB by AB, isn't it? So you can write it as OB divided by AB. OB is the displacement x and AB is the length of the pendulum. So that is L. So you can write F is equal to mg x by L. Now the moment you will write x, then you have to understand that you have to give a negative sign here. Why you have to give a negative sign here? Because you see, x is in this direction, whereas f is in the opposite direction. So as x and f, they are in the opposite direction, what you can say, F is equal to minus mg x by L. So you see, you can write what is the acceleration. Acceleration is force by mass. So acceleration is minus g by L into x. Alright, so you see in this one, what are you getting? Acceleration is directly proportional to the displacement and the negative sign indicates that acceleration and displacement, they are oppositely directed. So it proves that it is a simple harmonic motion. So you see, as I said it already, acceleration is minus d by Lx. So you can write acceleration is directly proportional to the displacement x. And the negative sign indicates acceleration and x are oppositely directed. And as you know, what are the conditions for a motion to be simple harmonic? That acceleration should be directly proportional to the displacement and acceleration should be opposite to the displacement. So that is proved. So what is the conclusion one can draw? That motion of a simple pendulum is SHM. So this is the question you may get. that how you can say that motion of a simple pendulum is SHM. Then you have to do this derivation. So this derivation is important for your exam. I repeat, this derivation is important for your exam. So do practice it kindly. So what you can say that motion of a simple pendulum is SHM. Then next is what will be the time period of a simple pendulum. So we know that when a particle executes simple harmonic motion, what is the time period? It is given by, in the last lecture we have done it, that T is equal to 2 pi under root displacement by acceleration. So look at this relation. From this relation, what are you getting? Displacement upon acceleration is equal to x by acceleration is equal to L by G. Isn't it? If you neglect the negative sign, why I am neglecting the negative sign? Because negative sign only indicate about the direction. That is not needed for time period. So you can see that displacement upon acceleration is L by G. So what is the time period of a simple pendulum? 2 pi under root L by G. So what is the probable question for your exam? From this topic, show that motion of a simple pendulum is SHM and also find the time period of a simple pendulum. So please practice this example. Next example of simple harmonic motion is horizontal oscillation of a mass attached to a spring. Alright. So suppose you have taken a mass, it is attached to a spring and you see it is suspended horizontally, not vertically. Now what you have done, so if you consider this A is the mean position of the mass, of the body of mass M. Now what you have done, you have just stretched the spring and you have taken it to the position B. You have stretched the spring by an amount X. Alright, then you know what will happen according to Hooke's law. I hope you can remember, you have studied it already. Hooke's law, what you can say, that a restoring force act on the body. What is that restoring force is given by minus K into X, where K is known as spring constant. This is known as spring constant or force constant, which depends on the material of the spring, and X is the displacement, and negative sign indicates what? Negative sign indicates that if the displacement is in this direction, then the restoring force will act in the opposite direction. Alright, so you see what will happen under the action of the restoring force. The body will first come here. When the body will come here, then X becomes 0, but force acting on the body will be 0. But what will happen? Due to inertia of motion, the body will overshoot this position because the body already has gained certain amount of kinetic energy. Okay, so what will happen? It will overshoot the position and then it will start moving in this position, just compressing the spring. How long? Till the kinetic energy becomes 0. The velocity of the body becomes 0. So you see, when the velocity of the becomes 0 after traveling the same amount of displacement x in the opposite direction, means this way. So you see, it will have a to and fro motion. Means if you just attach the spring and release, what will happen to the body? The body will have to and fro motion between the point B and C. I have drawn it on the different line, but actually it will be on the same line. It will just move to and fro like this. So it will have a oscillatory motion. Clear? Now we have to prove that it will be a simple harmonic motion. So if we apply our concept that what is the restoring force acting on it according to Hooke's law, minus K into X. So you see what will be the acceleration? It will be minus K by M into X. So you see what are you getting? That as acceleration, from this relation it is clear, acceleration directly proportional to displacement, and negative sign indicates acceleration x are oppositely directed. Alright, I am writing in short. So these 2 points together proves that the motion is SHM. Alright, the motion is SHM, and as it is SHM, what will be the time period? 2 pi under root displacement upon acceleration. So in this relation you see x by acceleration will be m by k. So m by k. So what is the time period of oscillation of the mass? when it is oscillating horizontally, it is given by 2 pi m by k. This is another important topic for your exam, that show that horizontal oscillation of a mass attached to a spring is SHM, and also find out the time period. Then whatever I have written on the whiteboard, that you have to write. That is the answer. Okay. Again I am repeating that please you learn and practice this example of SHM. Now we have to consider this, that horizontal oscillation of a mass attached to two springs. Alright, there are two springs. Now here you see in that diagram, two springs are having different spring constant K1 and K2. Alright, now these two springs you can attach again in two types of combination, series combination and parallel combination. And as you know, series combination means one after another, one beside another. So here you see this combination is known as the series combination. Clear? So in this case, if you consider that you have displaced the mass by x, means you have just stretched it by an amount x. Then what will happen? The first spring, it will be displaced by an amount x1. Second will be displaced by an amount x2. Let us consider. So what you can write, that total displacement will be x1 plus x2. Means both the spring will suffer different amount of displacement. x1 is the displacement of the first spring. x1 is what? Displacement of first spring. And x2 is the displacement of the second spring. Alright. So you see what will happen. The total displacement, one can write it as x1 plus x2. Now the question is, what will be the restoring force acting? Now you see restoring force acting on the mass. Either you can write minus k1 x1 or you can write it as minus k2 x2. Is that clear? What is the restoring force acting on the mass? Either you can write minus k1 x1 or you can write minus k2 x2. Is that clear? So you see, one can write x1 is equal to minus f by k1 and x2 is equal to minus f by k2. Is that clear? So suppose this is the first equation and this is the second equation. So if you substitute equation 2 in equation 1, what you can write? X is equal to minus f by k1 plus, it is minus f by k2. You can write it as minus f by k2. Is that clear? Everybody has understood? I hope so. X you can write it this. So this is the third equation. Clear? Now the next concept is that here only I am writing that instead of taking two spring, you have taken one spring of spring constant k in such a manner that it is undergoing the same displacement x and just having the same restoring force acted by same restoring force F. Then that is known as the equivalent spring constant. So you see from this relation what you can write, F is equal to minus Kx. You can write F is minus Kx. So X is equal to minus F by K. Clear? So if you substitute, suppose this is equation 4. If you substitute equation 4 in 3, what you can write? Minus f by k is equal to minus f by k1 minus f by k2. Alright, now no way out. I have to rub it. So you see, from this step, minus f by k equal to minus f by k1 minus f by k2. So minus f you can cancel from both the side. What are you getting? 1 by k equal to 1 by k1 plus 1 by k2. It means k will be k1 k2 by k1 plus k2. This is an important relation. For solving the numericals you have to use, and this derivation also it may come. And this k, it is known as effective or equivalent force constant of the combination. combination. So you see what will be the time period of oscillation of this system? It will be 2 pi m by k. Now what is the value of k? If you substitute, then you see k1 by plus k2, it will move up. So it will be m into k1 plus k2 by k1 plus k2. So you may get question from this topic. This topic is also important for your exam. You must learn the entire derivation, and the probable question is that show that time period of a mass executing horizontal oscillation when connected to two springs in series is given by that T is equal to 2 pi under root m k1 plus k2 by k1 k2. Alright. It means that you have to learn the entire derivation, and please you practice it also by writing it several times. The next is the horizontal mass, the horizontal oscillation. But the mass is connected to springs combined in parallel. So look at it. It is parallel, everyone understood. But why you may consider it parallel? Just you see, in both the side it is attached and then it is connected to the mass. Alright. So you may consider that both the side, these two are coming together on the same side. So it is giving the parallel combination. And not only that, in parallel combination, the first thing is that both the spring, they undergo the same displacement x. So you can understand it here. But what about here? You just see, if you displace the mass in this direction by an amount x, then this spring will get elongated by an amount x, and this spring will be contracted by an amount x. So this is also parallel combination. In parallel combination, both the spring undergoes same amount of displacement. Alright. That's why they experience, both the spring experience different amount of force. In series combination, what we have seen, this is the important difference. You have to understand it. That electrical series and parallel combination, you can remember. In electrical connection, what we have done? That when it is series, current is same, potential difference different. But when it is parallel, current different, potential difference same. Like that, in this connection of series parallel combination of springs, what are the points are same and different, that you have to understand. Same, I mean to say constant. So in case of series connection, the displacement was different, but both the spring experience the same force. I repeat, in series connection, both the spring undergoes different displacement, but both the spring experience same restoring force. X was different, F was same. But in case of parallel combination, what is happening? Both the spring undergoing same displacement, X is same, but forces are different. So what will be the force acting on the first spring? It will be minus K1X. What will be the force acting on the second spring? K2X. Is that clear? So what are the total force acting on the mass? It will be F1 plus F2. It means minus K1X minus K2X. So you can take you can take X common, minus also common. So minus K1 K2X. This is the relation you have got. Is that clear? Now, again the same concept of equivalent spring is coming. What is the equivalent spring? Instead of two springs, you will use one spring of a spring constant K in such a manner that total displacement and total force, it remains the same. Just like the concept of equivalent resistance in electric circuit. That is the advantage of physics. You know that in different cases, the same kind of concept we use. So the concept of electrical resistance is there, series parallel combination. So the same thing here we are using. So what is the concept of equivalent spring constant? That instead of using two springs, we have to use a single spring of spring constant in such a manner that the total displacement and total force remains the same. So that's why you see here, what is the total displacement X, what is the total force F. They are the same. So you see what you can write. F you can write it as minus Kx. This is equation number 4. So from equation, sorry, not 4, 2. equation number 2. So from equation 1 and 2, what are you getting? You are getting minus kx is minus k1 plus k2 into x. So what is the equivalent spring constant? K is equal to k1 plus k2. This is parallel combination. You can remember in case of series combination of electrical resistance, we got it. R is equal to R1 plus R2 plus R3, so on. You can remember. But in case of spring, in parallel combination, we are getting the same relation. K is equal to K1 plus K2. So you see here only I am writing what will be the time period. Time period will be 2 pi m by k. Means you can write it is time period is m by k1 plus k2. So this derivation also you must learn and remember. This is the derivation for parallel combination, and in parallel combination what is the expression for equivalent spring constant? K1 plus k2, same as that for series in electrical resistance. Next topic is vertical oscillation of a mass suspended by a spring. So look at the diagram. The spring is suspended vertically. Now in this case, you see, before the suspension of the mass, the length of the spring is bigger. Now when you suspend the mass, then what will happen? Due to the weight acting in the downward direction, there will be a permanent elongation of small l of the spring. So under this condition, what is happening? Just understand it, that F is becoming equal to mg. The restoring force is acting in the upward direction and mg is acting in the downward direction. So you can write that F and mg, they are equal. Alright. Now again, according to Hooke's law, what will be F? F will be K into L. Isn't it? Because according to Hooke's law, you know, force and displacement, they are directly proportional. So it will be some constant into L. So you see what you are getting? K into L is equal to M into G. Is that clear? So this is the relation, and you remember that M by K, what are you getting then? M by K is equal to L by G. This is the first relation we are getting. Clear? Next, what you are doing? Now, due to this elongation, already it was down by an amount L. Now, further, you have displaced it by an amount X in the downward direction. And it is released. Alright, it is displaced by an amount. Look at the diagram. The diagram is very important. You must practice it. This is the one original length of the spring. Then due to suspension of the mass, permanent elongation L. Then further you have stretched it down by an amount X and then released. Then what will happen? What will be the restoring force? I am naming it as F dash. Why? Because already F I have used here. So, what will be F dash? Restoring force acting in the upward direction. According to Hooke's law, it is given by minus K into X. Is that clear? So, you see, what will be the acceleration? Minus K by M into X. Isn't it? So, you are getting that acceleration is directly proportional to S. And not only that, this negative sign indicates acceleration and X are oppositely directed. So, what is the conclusion? Therefore, the conclusion is the motion is SHM. Is that clear? Then the next question arises, what is the time period? Time period is given by 2 pi under root displacement upon acceleration. So you see here, displacement upon acceleration will be m by k. So you can write it as 2 pi m by k. Again you are getting here m by k is L by G, where L is the permanent elongation of the spring. So you can write it as 2 pi L by G. So this is the expression for time period of oscillation, vertical oscillation of a mass attached to a spring. This is also important for your exam, and the probable question is show that time period of the vertical oscillation of a mass attached to a spring is given by 2 pi under root L by G. Then whatever diagram, whatever I have written on the whiteboard, that you have to write as the answer. So next is vertical oscillation of a mass suspended by two springs. Again, you know, two springs means there are two combinations, series and parallel. As in details we have done it for the horizontal one. Here I am doing it together. Okay, one by one we will do, but doing it together, sharing the same board. So suppose in series combination means it will be suspended like this, one after another. So in this case you have to remember what is different, x different, and what is same, f same. And we have got that total displacement is given by x1 plus x2, and the restoring force for both the spring you can write it as minus k1 x1 or minus k2 x2. Is that clear? So you have got from this one that x is equal to x1 plus x2. You can write it as minus f by k1, then minus f by k2. Then the concept of equivalent spring is coming. Means you have taken only one spring of spring constant k in such a way that f and x remains the same. In that case, what you can write, f is equal to minus kx. Is that clear? So what are you getting? So in this case, what are you getting? X is equal to minus f by k. So if you substitute it here, you are getting minus f by k is equal to minus f by k1 minus f by k2. So 1 by k is equal to 1 by k1 plus 1 by k2. So k is equal to k1 plus k2 by k1 into k2 divided by k1 plus k2. Is that clear? So this is the relation, the same relation as you have got for the horizontal spring. And what will be the time period oscillation? 2 pi m by k. So m by k means it will be m into k1 plus k2 by k1 into k2. Is that clear? It is k1 into k2. This is for series combination. Now for parallel combination, what is same? X is same but f is different. So what you can write? F1 is equal to minus k1x and f2 is equal to minus k2x. So what will be the total force? F1 plus f2 means minus k1x plus minus k2x. So you can write it as minus k1 plus k2 into x. Is that clear? Again, if you use the concept of equivalent spring, means instead of two spring, you have taken a single spring of spring constant k in such a manner, total force and total displacement remains the same. So in this case, one can write f is equal to minus kx. So if this is equation 1, equation 2. So if from 1 and 2, what are you getting? That k is equal to k1 plus k2. So what will be the time period of oscillation? 2 pi m by k means 2 pi m divided by k1 plus k2. Is that clear? So in both the cases, in case of horizontal oscillation also, in case of vertical oscillation also, the last result is same for the series combination and for the parallel combination. Okay. So please learn all these examples of simple harmonic motion, the simple pendulum, and then horizontal spring, combination of two springs for horizontal oscillation, then vertical oscillation and combination of two spring in vertical oscillation. That's all from this chapter. The rest of the topics given in the book, they are not in your portion, so don't have to study that. And this is the end of the simple harmonic motion chapter. Thank you, children.